Hey folks, it's Bruce, and we're still working on our Tetris game, and right now we're working on the game mechanics. So we just looked at, so as we move this, it can go off the screen, and we just built a function to detect collisions, and now we need to kind of wire that up in a user-friendly API. So rather than build this into the individual APIs that we have in Brick, and points and bottom, let's go ahead and wire it into Tetris. And so this is what I want the API to look like. Let's go ahead and code that up in the test. So this is going to be in a Tetris test, and we're going to go ahead and strike the .test, and we're going to import and we're going to alias. Let's go ahead and alias what? We'll alias Tetris. We need a brick. And do we need points? I'm not sure yet. Let's go ahead and use those two as a starting place. But this is the way we're going to check things. So we're going to try to move right, and it's going to succeed in this test. And we'll just copy the test to check the other API. And so what I want to do is say brick equals brick.new. And recall that this is the API that gives us a standard brick that's repeatable for our test. So this is the new, and it basically is going to create it with our default attributes. And we can go ahead and pass in a few extra attributes if we want to. Like maybe we want to create one with a location that's exactly where we want it to be. I think that we'll go ahead and do that. So we're in our Tetris test, and we're going to set a location of, let's say, 5. And this is going to create a default shape of, let's see, the brick test, or the brick, it says the default shape is an eye, and I think that we centered that at 2, so I should have room to move right on this. So I'm going to say new, or let's say expected is equal to brick, and I'm going to call brick.right. So we're expecting this thing to move to the right because there's room. And the actual .try right, and we're going to pass that a brick, and we're going to pass that a bottom. And the nice thing about this is that we don't really care why there's a collision. We only care that there's a collision. And we've already checked the ability to check collisions at the right and left boundary. So I'm going to try to move to the right, and I'm going to pass the bottom right there. And then assert. So let's try that test. Okay, that's not going to work because we don't have an implementation yet. So let's go ahead and build out that implementation. And so in this Tetris, we're also going to build to prepare a function that takes a brick. And this is going to look a lot like the other one. And let's go ahead and do an alias. And what are we going to need? We're going to need the bottom and a brick. So the brick we're going to need for the prepare, and the bottom we're going to need for the comparison. And I think that ought to get it done. I don't think that we need. Oh, we also need points to actually move the brick. So we're going to do here and we're going to call brick.prepare, and then we're going to basically move to location. And let's look at what that looks like in here. So this is exactly what we're after. So, but we went ahead and aliased that, so we don't need that piece. Okay, so basically what this is doing is preparing this and generating the points for us. So now I can say def try move, and I'm going to take a brick and a bottom. And so this is actually going to also take a function, right? And so so the try move, so the first job is to create some points, because our API in the bottom, the collisions, basically can take a list of points with or without color, and we're going to use the points without color. So the first thing that we want to do is, and then we're going to basically pipe it. And when I pipe to an anonymous function, I'm actually using pipes use invocations and not just the anonymous functions. Can I do that? No, I think I have to do that. And so then I also have to call prepare. So this does my move. And now, so this might have been left or right or rotate, and then I call the prepare, and the prepare actually moves is exactly the points that I would use in the application. And now we want to see if there's, so this is a new, actually let's do it this way. New brick is equal to F, right? And then I'm going to say, so prepare, right. Okay, so now this is going to get me the points. Now I can say if I'm colliding, and remember this API is going to take the bottom first. If this collides with that, I want to basically pass the brick before I move anything. Otherwise, I want to pass a new brick back. Okay, so I think that this gives me a try move, but now I need, so this is just glue code that I'm going to use to call the function from all the other places. So let's go ahead and establish those places. So so I'm going to say def left. Let's try this. Now I have a brick and bottom. And I'm going to one-line this basically because I'm going to want to see I'm going to want to see this try move. I'm going to want to see the function that I pass into that. That's going to take a brick, and the function is at .move or .break.left/1. Yeah, so now what's nice is that when I line these up like this, this is going to be right, and this is going to be right, like that. And then I have another one. This is going to be spin. And this is going to be spin 90. Okay, so that's nice. I like this API because this will tell me if there's a collision And if there is a collision, I'll go ahead and throw the previous brick back. And if there's not a collision, then I'll be happy. Okay, so now our job is to try to make these tests pass. So okay, so I've got a collide function that's not okay because I didn't qualify that with our class. So okay, let's see. So try write is undefined or private. Try write 2. Okay, so I don't want try write. I really want to actually this is a try, isn't it? So my convention is that I'll use try when something may not succeed the first time. So let's see if we can make this much work. So the try, okay. So bottom.collide2 is undefined or private. So I called collide with my bottom and with my list of points here. It's funny, if you heard the door open, the dog likes to be in with me to sit on the floor while I code. I have no idea why. So okay, so now we're getting an undefined Tetris bottom collide 2. So COLLIDE 2. So let's double check that we have something that we expect. So so the bottom, and then I have collide. Oh, it's collides plural. That's why. Def collides. Okay, check that. Okay, unused import of Tetris. Import of Tetris. Okay, so I bet that in my Tetris test, yeah, basically we're going to try to use that. It's a little bit lighter weight, probably not a huge deal. Okay, so it looks like our test is working, and now the next chunk of work that we have to do is effectively merge with the bottom. We have to work our merge with the bottom in with our down. So I think that what I'm going to do is do a down or merge or something like that. So here's what I want the API to look like. Test down or merge. Oh, you know what? I think that we need another test case here. I don't think that we've proven everything that we want to here. So I should return the original brick. So basically, if I'm an I, and I'm already at, let's say I'm at 8. So if I'm already at 8, then the first point is going to be at 10, and moving right should fail. So expected is equal to just the brick, isn't it? So this should, yeah. Cert. So I don't expect any change at all there. So let's see if that works. Expected so assert that the So the actual, yeah, sometimes my brain doesn't like to process those left and right side things. Okay, so look, so it looks like we moved right. So so we didn't get a collision. So we need to look at why that is. So we started with a location of 8 and 1, and I bet that so let's look at what this is. A great debugging trick is to pipe to IO inspect. And another one is that this is the test that's failing. And conveniently, I can code I can drop that particular test in and only run a single test. And I actually looked at those individual points, and this is great. This gave us exactly what we were expecting. So so we did our prepare. So I wonder if we did our prepare. So we did our brick.prepare. We didn't prepare our new brick, did we? We didn't ever prepare this thing. So this is a oh no, that we oh, here's the problem. This should be the new brick. Yeah, so I didn't prepare it. So actually I passed the wrong one in to prepare. Okay, so it looks like we're working now. So we're out of range, and so we returned the old brick. Good thing that we tested that. So now the next job is to first clean this code up so that my tests don't produce the extra output. And now they don't. And now I can run the broader set of tests. That looks good. Okay, so we have changes to the Tetris and the brick. So okay, so now I can change back a directory. And update the Tetris dependency. Okay, and so now, so we have the extra code. We can integrate this into our LiveView. So rather than calling, so now we have to think about our move right and our move left. So this is going to be Tetris.try left. And then that's also going to take a bottom. And so initially, just to check this out, let's pass the bottom like that. And let's see if we have our API right. So the Tetris is right here. And we want to try left, and it takes a brick and a bottom, which is great. So that means that we can pipe just like we want to. And this is Tetris dot, and this is going to be try right, and we're going to pass the bottom. And this is Tetris try spin 90, and let's see what we call this thing. Was it just spin, or was it spin 90? So that's in here. So try spin 90. Yep, so that's the correct API. But this one needs just like that. Let's see if we're going to work. Oh, okay. So we're crashing. You saw the red reload there. Oh, okay. So I bet that we need to restart after we fetched our dependencies. Okay. That's good. Okay, so we are off by 1. So it's not letting us move off to the left. So there's 2 possible things that could be messing with us. One is that we might be okay, yeah, so the rotate, so it thinks I'm at the left boundary, and so it's not letting me go around anymore. So the rotate, so we're basically working, but we're off by 1. And let's see why that is true. That could be 1 or 2 reasons. One is that our math is wrong in where we're checking the collisions. And one could be that our math is wrong, that we are actually not putting the new points into the live view. And I think it's a great place to take stock. We'll check that problem out next time. So again, the problem that we're looking at is that we're not going, we're going all the way to the off the screen on the right and 1 from the off the screen on the left. So I think that we're going to find that that our math is wrong when we actually put the results of the brick into our tetromino list. So this is a pretty good place to take stock. We'll go ahead and pause things right here. And when we come back, we'll look at some debugging techniques. And then as we're doing that, we'll sort of clean up the user interface where we're passing the bottom through cleanly. And then we'll probably also get to merging the bottom pieces in conjunction with a move down. So that's what we'll do next. Stay with us.